So to put everything together that we've been doing, we're going to look at shaded and composite area and perimeter. So big thing is composite. Students usually see that word and they freak out. Composite just means several shapes put together, like a composite material. You can have a composite metal where you have several metals that you put together to form one metal, or composite wood, or any material. Anything that you take several things and mix them together is a composite. So a composite area is found by adding the areas of all the figures. Now, you can break this shape into whatever figures you want. So we can make it into a 7 by 7 square, and we can add a 14 by 7 rectangle. We could also turn it this other direction, and you could go this same direction. Now, pay attention, because this is 7, which means this 7, and that just happens to cut that 14 in half. It's not always going to be in half. But then we can take this 7 by 14 rectangle and add to it a 7 by 7 square. Now, notice it's not any different. You're going to get the same area. Now, a shaded area, which I could ask shaded for either one of these, but in this case, what you see is that I have a hole in the shape. When you have a hole in the shape, you have to subtract. Now, you could, just kind of as a side note, you could go, okay, well then how much is this? And you could find the whole thing that's 14 by 14. And then you could subtract this little square right here. So there are several ways that you can look at this. It's not always if it's a whole, it could also have a piece missing, right? And so it could have a piece that's chopped off of the end or cut out of the end. It all just kind of depends on how you see it. And so we take the big square that's 8 by 8 and we subtract the smaller square that's 4 by 4. And that would give us this leftover shaded area. I don't need to paint the whole 8 by 8 piece. I just need to paint the frame. So we want to take these and break them into pieces. Well, the easiest, most logical one that you can see here with this arrow is to break it into this rectangle that is 30 by 50 and the triangle that is 30 by, now we don't have explicitly, we don't have this listed, but we do know that this side is 30, and then we know that these two pieces, that's 5 and that's 5, it's given, and so we add 10 more, so my triangle has 40. So the area of a rectangle is base times height, so we would have 30 times 50 plus the area of the triangle, which is half the base times the height, so we would take 40 times 30 over 2. So you would have 1,500 plus 600, and you would get that the total area is 2,100 centimeters squared. Now, in number 2, there's several ways you can look at it. You could say, okay, well, I see this rectangle that's 19 by 18, and then I want to subtract out the triangle. Totally works. You could totally do that and then add the circle. So you could take this as one whole piece, 19 by 18. You could then subtract out the triangle, which is also 19 by 18, so it's half of it. And then you could add the circle on top of it. That's one way to do it. Or what I see when I look at this is I see the triangle. Now remember, the radius is the same all the way around the circle. And so this one's 9, this one's 9. So the area of this triangle is 19 times 9 over 2. And so is the other one. That's 85 and a half. The other one is identical, so it's 85 and a half also. And then this is a semicircle, or half a circle. So the entire circle would be pi times r squared, 81 pi, and that's divided by 2 because it's half a circle. And we would add those together. So we take 85 and a half times 2, and we add half the circle. So we could do 171 plus 81 pi halves if we wanted to leave it exact, but if we want to find our approximate, and it says round your answer to the nearest tenth, which means use pi, 298.2, and round to the nearest tenth, 0.2, and that would be centimeters squared. Now, what if I have a hole, or what if I have a piece missing? So I originally can imagine that I started with this whole rectangle. Well, what you have to be careful of is, remember, that radius is the same all the way around. So that means that's 10 and that is 10. So the side of that rectangle is 20. So I'm going to take that 20 by 15 rectangle, base times height, and I am going to subtract my pi r squared divided by 2 because it's half of a circle. So don't forget. So it's pi r squared divided by 2. Now, exactly, that would be 300 minus 50 pi. Okay, 100, right? This is 100 times pi over 2. 2 goes into 150 times. That would be my exact answer. But if I want my approximate answer, then I need to use decimals, which means I need to introduce pi. So you would type in 300 minus 50 pi, and you would get 142.9, and that's square feet. Okay, so 4. On 4, I have a big rectangle. That rectangle is base times height, so it's 21 times 30. So 21 times 30 is 630. And I'm going to subtract 2 circles. So I want to subtract 2 pi r squareds. And both of those circles are the same size. So it's 630 minus 49 times 2 is 98. And then that would be pi. That would be exact if I asked for it to be inexact answers. But since I said to round to the nearest, I'm going to type it in. So 630 minus 98 pi is approximately 322.1 square yards, or yards squared. So this last one, what you have to figure out is you have to use the measurements that you were given with the points that you were given. So if this is a rectangle and in this circle and it centers around 0, 0, then if this is 3, 4, then what I know is that my horizontal is 3, and then I went up 4. Well, since it's a rectangle, then I'm going to do the same exact thing. It's centered on 0, 0. So I'm also going to have, it's going to go 4 down. That means the entire length of the side is 8. And then we also would go back 3. So that means the entire length of this side is 6. So I can find my rectangle. I start with my circle. The circle has a radius of 5. Because I'll go over 5, 0. Now you can draw your radius in anywhere. In fact, if you do it here, 3, 4, 5, there's that right triangle. You can draw your radius in anywhere, but since you have this point that's given, that's the one that's most useful for you, so we're going to use a radius of 5. So I started with the circle because that's the shaded part. I started with a circle and then I took away the hole or the rectangle. So my circle would be pi times r squared. And then I would subtract the rectangle, which is 8 times 6. So it would be 25 pi minus 48. That would be my exact area. And then if you type that in your calculator, 25 pi minus 48, you get 30.5 approximate. And that's in units squared. Okay, so when you have a composite, if you have figures that have been tacked onto each other or attached to each other, we don't have an equation for finding a picture of an area of 1 or of 2 as the shape itself, like we do a parallelogram or a triangle or a polygon or those other shapes. But we don't have one for an arrowhead. And so we have to break it into the shapes that we know. If you put shapes together, then you add, and if you take things out, then you subtract.